Okay, so we are live. Hello, everyone. We are AI Friday group
Yeah,
in the
Friday
Core
group.
Newbie channel. Yeah,
I'm
so
Russ, uh,
I'm Mo.
and today we got a big helping of AlphaGo. I think,
Yeah, it's been a big week for artificial intelligence, and I think the
especially
most
if you ask the internet.
uh-huh, everybody's excited for AlphaGo and how AlphaGo won against the South Korean grandmaster of the Go game. I can't
Yeah,
pronounce his name right. His
Lee Sedol. Is that
Lee Sedol. Yeah, Lee Sedol. And Sedol is actually two two different portions. So it's C and Dol. I've read some articles where it's just
uh,
one
yeah,
word.
I was about to say that what I just said is a very American way of saying his name. I'm sure.
Yeah.
um, yeah.
But
Uh,
I mean, props to the guy. I mean, yeah,
yeah.
he's done well.
Yeah, he did win one of the matches.
Hmm.
So uh, before we dive into it, I guess quickly, of course, for some people, like that is a great thing because they're so worried that AlphaGo is so smart that
Yeah.
human beings are incapable. It's already far surpassed our intelligence or something. I guess we should probably start by talking about why Go and winning at Go is such an interesting thing for our computer to be able to do.
Hmm.
I don't know if you wanna. You're welcome to take that, or I can take that. I don't know.
Okay, I'll just start with just explaining what happened actually for
Sure. Yeah.
somebody who's
Why don't you do that?
so Google announced it has a new algorithm to so it's been a tradition so far over the many years that computer scientists are trying to invent algorithms, gaming algorithms such in chess, tic-tac-toe, whatever, many board games to and try using these algorithms to defeat the grandmasters of that game at that time. So we've seen this before in 1997 at chess when Deep Blue, IBM's Deep Blue, won against Kasparov, the Russian chess grandmaster, and then it's been many years, I think almost 20 years since we've waited for for an algorithm to come and beat the grandmaster at the Go game. Go is an ancient Chinese game that's played with darts, I guess, and it's very complicated. So this week, starting from was it the tournament started on March 10th?
Uh, I don't know.
I
I can
suppose
look it up.
4 days or 5 days. Yeah, let me check that too.
I don't know that it really matters that much. Uh, let's see.
So,
Uh,
2015, October 2015, Google announced that it's going to they're going to get their tools, their algorithms, and everything set up to beat one of the grandmasters, namely Fuji something, I think. I don't know his name, but the gentleman is considered to be one of the grandmasters of the Go game, and AlphaGo beat him 5 games in a row. So the
yeah.
machine, yeah,
Well, yeah, but I think he's ranked way lower than
yeah,
Lee Dahl.
yeah.
Um, so I guess to get into something a little bit, just to get into the details of it, a little bit in terms of like actual real content here. Uh, why is Go so much more? Why is Go different from chess? Why is it that we've been able to beat chess for a long time? Why is Go different? And why are some people all up in arms about AlphaGo winning at this game? Um, what you might hear on the internet or whatever is that you know you can't brute force win Go, And specifically, I mean, and that's true. The Go board and the way that it works is set up in such a way that it's very different from chess. In chess, there's a very limited number of moves that you can make per turn.
Mm-hmm.
And while more complicated than Connect Four or Tic Tac Toe, it's still a limited enough set that the way that pretty simplistic AI could do it is by simply knowing, well, if I look at all the moves I could make, and then I look at all the moves you would make in response, and then all the moves I could make in response to that, and then all the moves you could make in response to that. If you can go deep enough, you can find the best moves on any turn. And that's basically what all these chess programs do. And combined with some additional logic to know openings and closings and some of that stuff, it's pretty easy for a computer to be really good at it. And the more powerful the computer, the easier it is to beat. Go has so many choices. I actually don't have the numbers in front of me, but it has so many choices that it is basically near impossible.
Yeah.
There's so many combinations of moves and orders because of the way the Go board works. There's a bunch of spaces, and every move you get to put one of your pieces on any open space on the board. That allows for far too many possibilities.
Mm-hmm.
And so you can't just brute force it the same way. And so, people have talked about Go, that it's really masterful Go players rely on intuition, and it almost has this mystical quality for people about it, which is of course kind of BS. But
BS, exactly. Science does not go around these myths of intuition can solve your problem or whatever. But just to complement your thought on how complicated Go is against chess in comparison. I mean, not to not to discourage people who love chess and tell them that Go is way more difficult than chess, but if we talk technically, the state space, how many possibilities you can for an optimal chess game against how many possibilities for an optimal Go game. So for chess, if we think of all the stars of the universe, of our universe, this would be the number of possibilities for all the moves in chess. Go is more like the total number of atoms in our universe. So there's a huge state space difference, and the human mentality has been always that, okay, if we lose at something, we either have to be stronger or bigger or faster, and all this is it helps, but it's not intelligent. It's brute force, as you said.
Right.
The more intelligent way is to think about the problem and understand the cases where the if-else cases where this is a more logical move than this, and this is what we mean by AI and how to make a machine make that decision at runtime without the assistance of humans.
Right. Well, I mean, and of course, the thing about AI, is that for very narrow tasks like this, we'll get into this in a minute, I'm sure, but for very narrow tasks, it's much simpler to build an AI that is focused on understanding the specific task at hand, designing algorithms and training against a very specific thing. And it's far different to do that than it is to understand like what a chess piece is. Like it's harder for a computer to understand like what a knight is. Like what is it? What is it really? What does it mean in the context of the world? Than it is to know what the perfect placement of that piece is. So
that's an excellent note. For a computer, you can teach it that, okay, a knight has these possible scenarios. It can move this way, it can kill this way, it can be killed this way. But for Go, where essentially each dart or each piece is equal with any other piece on the board. So the possibilities are limitless even on the single dart level. So it makes it simpler, but it's also more complex if it makes sense.
Yeah, yeah,
It's more of each piece is a very generic representation of a unit.
yeah, yeah. So we had some articles that we had pulled aside around this.
Mm-hmm.
I don't know. I guess I don't know what you want to talk about next. If we want to stay on more technical details,
Yeah.
um, just in terms of what's powering, the difference between these. So going back to what we talked about with chess. So chess is mostly brute force. There's a common algorithm, and I know that there's more to. I don't want to oversimplify, but the algorithm I was describing for brute force in chess is called, the min-max algorithm. It's well known. It's pretty easy to implement. It, in fact, I think is a great code newbie AI thing to do, is to implement min-max for some game like tic-tac-toe or something. But AlphaGo uses an entirely different algorithm and way of doing AI that is much more just based on pattern matching and learning than brute force. So the architecture of AlphaGo is something called a neural network, which computer scientists have been using and playing with for a really long time. I'm not strong enough in this area to know the specific details about what makes this one special or different, but basically it kind of mimics a little bit of the way that our brains actually work. Our brains are a neural network. That's why these are called neural networks. They're based on the way our brains work. And it's very much about learning through patterns and experiences. And the way that they trained AlphaGo is by first studying 30 million Go matches from actual human games, and then they started having it play against itself to then get even better. So it was all about learning, as opposed to chess, which is very much, when they do those, it's very much upfront. It's like, first of all, you've got this brute force, and then, combine that with, known qualities about chess, known openings and closings. This was like, you're just going to learn by playing. You're literally going to learn, and we're literally going to teach you.
Exactly.
And it's all about pattern matching. That's what our brains are really good at. Our brains are really good at pattern matching. That, so many times we can't even describe why. And this is what intuition is, right? Like, this is, if you're talking about brains and neuroscience and intuition, that's what intuition is. You don't know the reason why. Your brain knows the reason why, because it's done it so many times, and that's why, they say people, experts tend to have good intuition. That's one of the things that gets you from, like, a mid-level person to, like, the utmost expert. Is experts are able to operate so fast and think so quickly and operate off their intuitions. Well, it's not like a gut, like when we always call it, gut instinct. It's not just like a sense. It's not magic. It's literally that your brain has done something enough times that it's able to recognize patterns and know what to do about it without it reaching the level of conscious thought. And that's basically what is going on here. And that's what goes on in Go, is you have these Go players. They've done it enough times. It's more than, I'm sure maybe there's unique qualities about an individual player, but they've done it enough times that their brain is really good at recognizing these patterns.
I agree with you on some things, but the most important thing that I cannot agree with is the notion of instinct and gut feeling. You're right in the fact that we do not know what it is, and our brain knows what it is, but this is because we're using our brains to understand our brains, which is a deep philosophical thought, I guess.
Sure.
But the thing I want to note is the so how did the entire community of um, computer scientists and artificial intelligence scientists moved from the thought of brute force to the idea of neural network? And why is this very important to us? It's exactly to answer that same thing, that we know that there is this thing inside us that we do not understand, and the only which is instinct again. But there must be a scientific way to explain it. So since we don't have any other point of reference to mimic that thing, so we're trying to mimicking ourselves. So we're moving now from the brute force way of if else, and using lots of computation to something more intelligent. And that is what I'm trying to get into now, is that we are trying to look, if we don't understand how our brain works, then let's open it up and check the anatomy of a brain.
Oh, and lots of people are doing that in different ways. And I mean, things like this may not even be a direct study of how our brain works, but it is certainly something that can be learned from, and the things we learn from it can be brought back to understanding, how our brain works. And again, I think that this is, proof for many people. I'm probably more the layman than the expert, but this is proof to many people that, that brains are, computers of a different kind.
Yeah.
Again, I know that touches on philosophical topics.
On a philosophical topic, but you're right. It's again, it's something we don't understand, but we want to model it in a mathematical, understandable way. So I have to say, or I have to claim, and it can be my own personal opinion, but all AI, all artificial intelligence, is based on human intelligence. Until now, AI is a subdomain of human intelligence. So there is no, and it's
Well,
even.
I guess I would ask you, what is human intelligence, and what is human intelligence versus animal intelligence versus bug intelligence?
Yeah, true.
Anything that we would call intelligence. What is it, and why are you even saying human intelligence? Because
It's
quite
because
frankly, many things that we would consider, artificial intelligence are honestly, many things are actually more based on insect intelligence or something, because it's so much simpler.
actually that is very true. Insect intelligence is part of AI. We have implemented algorithms just to mimic the way most of the brilliant search algorithms are based on how ants go out and seek their food, and how they leave pheromones on the ground just to make their clan know that, hey, somebody went this path, so maybe at the end of this path we will find food. So I'm saying human intelligence just to, again, to emphasize this thing, which is because, again, what is intelligence? We have to have a point of reference to refer to intelligence. What is smart to us is might be or what is smart on the scale of ants is trivial and super stupid for humans. Trivial intelligence. So I'm saying AI is a subdomain of human intelligence, just to say that there is a point of reference, and all our efforts right now are mundane. We have this thing, our brains, which we don't understand. We're streamlining parts of what we are doing well, and saying, "Hey, we've created this new monster. Oh, AI is going to take over the world." It's actually, it's we are I mean, we are we are way too cocky. Again, I want to go to AlphaGo because everybody was scared when an
Sure, yeah.
electromagnetic.
Go
Yeah,
back to AlphaGo, absolutely.
everybody was
Uh,
scared, that, oh my God, this new machine is taking over the world, and but it's
oh yeah,
actually.
no, sure. Yeah, well, yeah, and again, part of it is specific, and there was similar when chess, um, when there was chess when computer, won at chess, there was similar talk.
Yeah.
Anyone who could sit down and rationalize about it, could easily see how it was so different, because it was so mathematical in nature, and so simple a process of just of brute forcing. But it is interesting because, and part of the reason for that is, of course, is because chess is something that we consider something smart people are really good at. So, if a computer is beating our smartest people at something we consider hard for smart people, then it must be smarter than that person. And of course, that's not really true.
Mhm.
So.
Also, I might deviate on just one point, but I just want to make everyone who might watch us or what, just to know that this is also part of a political scheme. So we know that Microsoft is coming up with their Open AI lab, whatever, and Google is doing the same thing with AlphaGo deep learning lab, and Elon Musk with his I don't know what. So it's also a publicity thing, and it benefits. It benefits everyone. Actually, it's a really good thing because it benefits Google. Number one, it benefits Google. It benefits even I forgot his name, Lee Sedol. Yeah, it benefits
Who?
him on the Grandmaster Lee Sedol.
Oh yeah, Lisa Dollar. Yeah.
Yeah, and it benefits everyone. Like, people are starting to talk now, and it's a good thing. It's a good publicity PR thing. So definitely, but let's not just go over our head and start, speaking about no, computers are taking over the world again. Like you said, yeah, we've been through this back in 1997 and even back in the 70s. Everybody's like, no.
Right. Well, and of course, this time it was, it was like, oh, well, we understand how it wasn't a big deal when it was chess, but now it's Go, and that was predicted to be really hard or impossible for a computer to ever be better. I mean, there were people who literally predicted, but of course, the people that predicted that a computer could never do it, of course, was thinking that someone would have to build a computer just like Deep Blue when at chess. I mean, obviously, something can learn patterns in a different approach. I mean, I guess that's what I find so funny, is that, people imply a lot more intelligence onto this thing that was able to learn patterns and learn Go well enough to beat a grand champion, and imply a lot of other context and intelligence to that isn't actually there.
Yeah.
Hey there. My
Hey.
opinion.
Sure.
My opinion on that is, when you have two humans which are face on face to each other, they read their submimics and stuff that a computer can never understand. So there are so much variables which go into intelligence more than just calculation. Oh, he put it there, and I have to do that. That's not a fact. You have to feel, and feeling is hard to make, I would say.
Yeah. Well, absolutely. I think the ultimate question, which boils down to philosophy, is yes, a computer couldn't do it now, but is emotional intelligence, is reading facial cues, is any of that stuff beyond the capacity of a human, or is it just really hard?
No, I mean, you brought in some of the notes that you have prepared. You've mentioned this idea of um, what did we learn from AlphaGo,
Right.
and I think just in the context of that, let's say in a scientific, a critical thinking way, especially in a game like Go, where you don't even have to see your opponent. We're talking about pure mathematics. Let's say, does it even matter if I see Lee Sedol or I don't think it's maybe in poker, maybe in another game that's true. If bluffing and emotions and talking to your peers and opponents is part of the game. But and also you've brought up this thought of AI versus AGI. Can you?
Yeah, I think that's a good. I think that's probably a good topic to intro. Now, even do you want me to go through what we have in the notes?
Yes, please. If you can go through.
Sure. So this was another article. I wish this was like, I don't know. I feel like we should have like show notes, like a podcast. But there's another. And actually, here I'm gonna proceed if you want. I don't know if you can get this or if it needs to give special access. That's a document that we put together. So there was an article, why AlphaGo is not AI, and I think it's interesting. It addresses a lot of things we were just talking about, and it tries to talk about artificial intelligence versus artificial general intelligence.
Yes, please go on.
Thanks. And basically that, like, this thing is a really narrow thing. It knows how to play Go, and it used some really interesting techniques to do that based on, you know, the way our brains work and learning, and it did all those things, and it's hard and it's great, but it's very specific to Go. It knows how to do Go, and it knows that without any context of what Go is or what human beings are or anything else, it just knows Go. And so the article tries to go into the, you know, artificial general intelligence, which is what a lot of people think of when they think of AI, when they think of a, you know, a computer with a mind of a, you know, like with an artificial intelligence capable of being like a human, right? Or, you know, well, can computers surpass human intelligence? They really mean that. They mean artificial general intelligence, that it could have a conversation with you and understand the words you're saying in the same way that humans do. One thing that they talk about, and this article brings up, is the notion, and that's, you know, exactly what we're saying, is meaning, the problem of meaning. And there was a paper, scientist Stephen Harnad had a paper called the symbol grounding problem, which is basically just, you know, a fancy way of saying, you know, having a computer understand the meaning of the things around it. Sure, it may be able to compute stuff, but it doesn't really understand. The difference between understanding and being able to take inputs and do some output. What's the difference? And we of course attribute humans as understanding and having a cognition and thinking, right? We don't necessarily give that same attribution to robots or artificial Go things or whatever, right? But we also don't give that to bugs, you know. And in fact, you know, bugs, you can look at a bug, and a bug is very much like a computer. There's very specific inputs and outputs that are practically mechanical, given how simplistic they are. So this article, again, it goes on to talk about that and why we shouldn't look at AlphaGo as going, oh my God, we're almost there. We're, you know, because we're not. We're definitely not almost there. But further, a very interesting thing that the article talks about is that to get there, to actually get to artificial general intelligence and to understand meaning and to have any concept of that, an AI will need a body. It will actually need to be an entity that interacts with the world, as opposed to just being an intelligence living in a computer.
That's true.
So, which is, I think, an interesting thing, and I apparently a lot of people agree with that. It's called the embodiment problem.
The embodiment problem, yes, which is a great point, and I think, I mean, and I've thought of that exactly. Like, if for anyone who watched the actual game, so Lee Sedol was sitting on one chair, let's say the red corner, and somebody, like a Chinese gentleman or a South Korean gentleman, which nobody knows even his name, was sitting on the blue corner playing AlphaGo's moves, like, manually. And for me, that demonstrates how we still don't understand what AI. I mean, for a child, if a child was
I mean, let's be
game,
clear.
they will see
Let's
two
be
people
clear.
playing
They
against
could
each
have
other.
built. they could have built a robot that could have dropped Go pieces on the board. They could have built that like I could build that out of a Lego Mindstorm kit. Like, it's not that hard.
It's not that
So,
hard.
like, I don't want to go that far to say that that would really make that much of a difference.
I mean,
but
for a company, from let's say from a marketing perspective versus a scientific perspective, for us maybe more inclined to scientific things. Yeah, it wouldn't mean much. But let's say if we're coming here as, yeah, this is a publicity stunt, and especially by Google, then Google should have thought of all these things already and made sure even children, when they watch this, they have the full experience of, yeah, this is cool. You know, there is a robot actually playing. And why I mean, since we're talking about this embodiment problem, which is AI having a body, so why actually not? I mean, you've said, yeah, it's really easy. It's not difficult to, and it wouldn't exactly fulfill the embodiment question here, but at least, you know, try to educate us and make us know that these two things go hand in hand.
Yeah, so one thing I will say about it that I think is interesting, right? I don't necessarily agree with the embodiment problem. I agree with the embodiment problem under some definition of the embodiment problem, which is that a computer or an artificial intelligence will never understand the world the way we do without having bodies. But that doesn't necessarily mean it couldn't be artificially intelligent. It would just be very different. And the fact is that one of the reasons why we have this notion of context, I mean, I don't know, in my opinion, I'm not a scientist, but, you know, one of the reasons why we say understanding the context of things, or understanding the world, or understanding the meaning of things, when we say the meaning of something, what we're really doing is we're associating a symbol, an abstract thing, with many concrete things, or even past experiences with those things. So, you know, if you were to talk about, you know, the meaning of love, or the meaning of a computer, or the meaning of a mug, you know, or coffee, or, you know, like, those words can be defined for a computer. But when we think, what we think of when we feel like we have real understanding or meaning of them is because I know how much this weighs. I know what it feels like when I hold it. I know that it's holding my coffee right now, and I know that I love the taste of coffee. And you know, and all of the pop culture references to coffee and the greater meaning in our culture, and that this mug is holding my coffee, and that's why I like this mug. And it's got a mustache on it, which is funny, and it's funny when I do this.
Yeah.
But all of those things, I can say them, and they're all very human things, and they're all things that a computer wouldn't understand without experiencing them. But is this meaning and grounding of meaning really just a collection of all those associations that I can only have by having a body? And we associate value to that because we have bodies and we experience them.
It depends on, I think you have like, I call it base function. So you know you're grabbing something, and then you have to know what this is. And the definition of intelligence is to connect that bottle to what you're saying it can hold water. But when you have like one understanding function where you can just throw input in, and the computer or AI learns how to interpret what this thing is, then maybe you get an experience from that. You don't actually have to hold it, because when you give the computer the input that this is water, and he already knows what water is, then you could create that.
Yes, and I agree, and I totally agree with that. I guess that's what I'm saying, is that I think that a computer can have those types of associations and be able to build up meaning. It's just going to wind up being a different kind of meaning than what a person would have.
Exactly. We as humans, I mean, Hello?
I mean, it's totally, yeah. it's it's totally personal what you
Exactly.
think or mind. And God must have like a personality to associate to their feeling.
Yeah.
And I think you have to build not one AI but a million of them so they can interact as unity. Because humanity is not
That's
just one
actually, I think,
thing.
a very interesting point. Yeah. What would they would have a completely separate world, but what if you did have? I mean, again, part of what makes us be intelligent and be able to have feedback and be able to grow as intelligences, and you look at the neural network thing, we have a reason. Like, part of it is you start at the base. We have a reason for being, right? We have a reason for existing, at least in the sense of survival and reproduction, right? If you want to just go with evolutionary traits, like survival and reproduction, those are important qualities that we have developed. So they're obviously things we care about, and so you have things like pain receptors to know like what's going on, pain and pleasure and whatever, because that's going to steer us towards the best path of surviving and reproducing at the very basic level. We'll just stick with that. What would it mean to have millions of AIs that are all interacting, right? If they have no a purpose in a way, they have no feedback, there's never, it's just random numbers moving around, right? Like, there has to be some aspect that would make it, learn. What is learning? With Go, we have a focused thing. You could almost express it as, and this is actually very true, the way neural networks work, they the same way in our brains when we learn stuff, it's neurons building stronger pathways to repeat those types of processes again. It's a reward system, positive and negative feedback. And so in a way, while I'm sure AlphaGo does not have a consciousness, as it were, you could say that it has pleasure in winning a game and pain in losing a game, because it's learning because of those positive and negative. The only way it's going to learn is if it knows this was good and this was bad for me.
Okay.
But at the end of the day, you brought up many things actually in just the last 1 minute. The notion of consciousness, the notion of reward system. These are core questions. Still, AI does not answer them. In a simplistic way, AlphaGo does not even know that it's winning or losing. It knows that there is a pulse, that there is an input that went into the neural network, and hey, that's the output I gave. even when it decides to resign the game, for AlphaGo, that is the winning move.
Not necessarily. That is the move it makes that the computer decided. But I guess what I'm talking about is learning and feedback, right? Now, we have very specific brain consciousness associations with pleasure and pain feedback and rewards, right? And we can say, well, the computer doesn't have those, right? And that's basically true, right? But we can say that the computer, is learning, and it knows the difference between whether something was good, because it will reinforce doing that thing, and when something is bad, because it will then not, it will maybe avoid doing that.
But who made the decision of this is a
no,
good or bad?
that's how neural nets work, though, right? It's based on whether you win or lose. There's not a person that said, hey, you did this, right?
No, it's part of the training set. So once you win, or once you're declared a winner,
it was programmed to it was programmed to know what good means, right?
No,
but there isn't a person telling it each time.
It was programmed to do an if-else that someone else wrote. It does not know the meaning of, that was a winning move. Or, I
guess the question is, like, we die, so we strive for a goal in our life. So when an IA could create children, So let's say he's winning. When he's winning, he creates an instance of his own with learning. He would have created something he could try for. And let's say the AI knows that it has created this children and it's better than me, and that's the goal of the AI. God, I can't say the word. And so it would strive for something. And let's say it has a life cycle of 3 days and it created 400 children, and the children would have the same amount of drive to create something new. Then you would have something like we humans have to strive for
I mean,
something.
that already exists in a way. I mean, it's called genetic algorithms, and I mean we do use those, and that would be probably an interesting topic for another day, where it's basically we model it in a way similar to our own, generations and mutation over generations, to improve. Which I think is interesting, but I guess back to my earlier point a little bit, and yeah, I mean I do agree. I don't want to be dismissive because I think that's a good
No
point.
problem.
But like when you're saying, oh, there's an if-else in the code, okay, well, why do I have pain receptors and how do they work? Because there's no difference really between me having pain receptors in my skin that when they get hot or when they get pressure in a certain way, that's negative feedback in my brain. There's not really that much of a difference between that and an if-else in the code that says, well, this type of input is bad.
Yeah.
But it's 5:45, so I gotta get going. You guys are welcome to keep chatting, and we could pick it up another time. Or so I don't know if you can end the call, but I have to go. So I don't know if you want to.
It was a pleasure, and I was hoping to keep going on because we still have a lot. But yeah, it was
I
a
know,
pleasure,
but
man. Thanks a
it was
lot.
a pleasure. You are welcome to keep going on. I have children and responsibilities.
No problem, man.
All right,
Thanks,
it was
Basil.
great talking. I'll talk to you guys later.
Bye. Bye.
Yeah. But
So we're still in call, but I think yeah, I mean for people who are going to visit the channel, maybe watch the video, they're going to go crazy because there is no. I think we just jumped deep into AlphaGo and consciousness, the brain, the mind, and we tend to do that all the time, and we tend to prepare beforehand with like a document where we write, hey, this is what we're going to talk about, and then we end up deviating miserably. But yeah, I mean, AlphaGo is a huge subject that we can talk about for days and days. Just the achievement itself was I pretty still have mixed emotions. It's cool what has been done, but it's still not cool.
yeah, it's kind of creepy.
Yeah, I mean, I don't know how to put it in words, but human intelligence is still way better than artificial intelligence. And I was saying that still AI is a subset of, instead of human, let's say natural intelligence, what we see on the natural world, whether humans and whatever.
I'm guessing if we ever hit the point where we can, say, Go is making a, like I said, Go, then we could create some create everything. Like I put the stool in that position because of that, and then the next step is there's a better way to put it in that position. And so if there is ever a global function which can learn input and output better input and connect that to a huge network, then it would be like a huge breakpoint. You know what I mean?
Yes, actually we are going in that way. The introduction of neural networks exactly tries to answer this global function thing. It's trying to mimic the human brain, because we already broke it down to, hey, we know we are intelligent, so let's break the anatomy of of the human being and try to understand what's the inputs, our five senses. And I know some people would say we have more than five senses. We have like 30 plus senses. But anyway, our senses feeding our brain and our mind, and then our responses are the intelligent decisions we make throughout our lifespan. So the neural network is trying to solve one part of that, is trying to replace the technical part of the brain. And I'm saying the brain, not the mind, because the mind is another thing that involves the consciousness, which is a huge field that still AI knows nothing about, actually. But yeah, neural networks in general are trying to fulfill that missing part of if we feed these inputs to these neural network, the neural network, our brains should learn, and from learning it should evolve and. So we are working towards this global function, as you.
Yeah, I'm just jumping into that. I never really got into AI before, so kind of interesting though.
Yeah, I mean, AI is kind of like the. I think sometime during the next 10 years, it's going to be. I mean, in the job field, like people will be hunting, or companies will be hunting for people who are specialized. It's actually happening right now, but I mean, it will be on a bigger scale, where an artificial intelligence scientist will be someone who's sought after. And but yeah, for some it's the cool thing, and that's good. It's publicity always helps when people identify something as being cool and rad. That's cool. It helps.
But the question is, for me, I kind of find it so creepy to know there is something which I gave my input to, and within milliseconds, it's more intelligent in that special task than I am. That's pretty creepy.
It's not creepy at all. If you broke down the problem and try to understand how neural networks work, it's actually very simple.
I don't mean like creepy is hard. I mean, it scares me. It scares me that a computer someday could just replace humanity.
No, that's way far-fetched. But why does it scare you? I can be scared if I don't understand. But if I understand, then there is no reason for me to be scared. Does it make sense?
Just no, because I get your point. But let's say someday, I mean, this was discussed over and over, but one day a computer learns that humanity is bad for the planet, and the planet is the thing AI, so it wants to survive. And okay, by humanity, just as an example.
Yeah.
And you have to restrict the AI to do that.
Yeah, this is also another point that I brought up in the show notes, which is a theory called Roko's Basilisk. I don't know if you're familiar with that.
Not really.
So it's a far-fetched theory for me, but it goes like this. Like, imagine if sometime artificial intelligence evolved to the point that there's consciousness, and it understands, and it does what humans do, and even more, surpasses humans in intelligence and everything, and whatever. So when this AI consciousness comes to life, okay, just imagine a world with this scenario. Okay, let's say our world, and that AI emerges, then it starts to punish people. It starts to punish us in a simple way. If you have tried to contribute to AI's achievement, then you will be pardoned. You're a good man, or you're a good Samaritan. If you have neglected uh, if you have neglected the notion of AI and never tried to contribute to AI, then you will be punished. And by punishment, you will be poor, you will be whatever, killed, whatever. So,
It's like an evil jitter.
yes. And the point
Yeah.
is at the end, so it's a reward system by an AI being that identifies people who have helped the achievement of AI, and those are the good people, and the other people who have never helped in that, then they are the bad people. So that's the Roko's Basilisk. And now, if we compare it to our world, then you see our world is already there is AI achievements in our world, and definitely people or groups like Google, Elon Musk, Microsoft. These are the people that are trying to bring AI forward. And at the same time, these are some of the richest companies in the world. So wouldn't you think that these people are already being rewarded by the the artificial intelligence consciousness or being, and people who are not investing in AI are already losing so many things and already being poor or whatever? So how would you know that the Roko's Basilisk experiment is not actually, we right now are not part of that experiment?
Because I think that there is no consciousness. So
But how would you know that? The theory goes like, how you just said there is no consciousness. You decided that, but I'm telling you all the reasons. Like, if you look at the people who are investing in AI right now are the most lucrative people. So
I
how
got
would
you,
you?
but I think, I don't know, but I think there is no intelligence. So we could go there and just shut the computer off, and there would maybe be no money, but we could turn it off. My fear is that there's a point where we can't shut it off.
That it's I mean, it's a theory, okay?
Yeah.
So
Okay.
maybe I wasn't really great at explaining Roko's Basilisk, but it's
So
worth
I got you. It is happening right now because the people
because
got
already
rewarded. Yeah.
the capitalistic system is rewarding people who are investing in AI and blah blah blah. Meanwhile, the other people who are not investing in this field, they're not really seeing much reward. So maybe that's why some of us lead a really good, happy life, and others are really miserable. Maybe the consciousness is already there. It's a philosophical game thought, I would say. But if you want to take it seriously, then yeah, you can come to some serious assumptions there. You decided there is no artificial intelligence, whatever consciousness. You decided there is no consciousness at all for any artificial intelligent being, and yeah, that's a really quick response to this theory.
I thought, I mean, it could be. It's a theory. It could be. So how would I know if Google invented something like that?
Yeah, maybe AlphaGo is just a publicity stunt, just to make you think that artificial intelligence consciousness is not there, while actually Google is the AI, or Roko's Basilisk in a sense.
Yeah.
But it's
How would
mean,
I just think we're not there? So
it's a
could be,
good thought experiment, and I suggest for anyone who's interested in some of the dark sides of AI, just to look it up. Roko's Basilisk, Roko, and Basilisk. Check it out. It's a really cool thought experiment, I guess. But on the other hand, we've got a lot. I mean, Russell has. I think he's covered pretty much AlphaGos, and he's provided some cool information about that. But on the other hand, coming to robots, I think we have a bunch of robots that got announced this week. And I think the most interesting one is DRU. So Domino's Australia, they announced their delivery robot. It's Domino's Robotic Unit, DRU, Drew, and they showed a video of actually how they conceptualized the idea and then went about collaborating and partnering with some tech firms to come up with the actual delivery robot. And I think it's really cool. At least it's I mean, many people have done robots. Most of them did it in a very stupid way. Some, like in Japan, they like the homemade sex doll, whatever. And in some other parts of the world where they did these, I don't know, stupid robots just to do stupid things. But at least this one has a purpose, a real life purpose. And I can share the link with you because it's really interesting. I know for the viewers they can't see this, but check it out. It's Domino's Robotic Unit, DRU. It's a really cool, I think, achievement, steering us into more commercialized robotics into real life world. That's a really cool thing, I think. And props to Australia actually for because Domino's is an American franchise, and for Australians to take the initiative and start this project all by themselves. So props to Australia and Australians for showing the rest of us that yeah, we don't have to follow, we can lead. That's really cool. And then there is another bunch of robots actually.
Well, I guess.
Anyway, so I think we've gone through some cool stuff, and yeah, I'm out of thoughts, but yeah, the main event was AlphaGo. AlphaGo was really cool. So,
Well, I guess Amazon. I guess they already made some drones which can deliver your packages. So it's a pretty similar thing, but not controlled by an AI. So
yeah. For me, it's fake until I see it with my own eyes. So I think they're still streamlining this thought, and they're still experimenting with it. Especially also Amazon. I mean, it's Amazon and Amazon Prime is really popular in the US. And I hear the US is facing some major regulation issues with drones in space, and they're still trying to regulate the laws and whatever. So yeah, it's still early, but I mean, Domino's Pizza in this case, the DRU is fully functional, and it's experimental, but they are actually delivering pizzas with this robotic unit. So yeah, let's wait for Amazon. But that's cool. Yeah, I mean, I'm all in for these kinds of efforts. Really cool.
Yeah, but then there is my fear again.
What fear? Of robots taking over the world? This is a highly popularized science fiction thought. I mean, yeah, people, I mean, the human beings are really cocky, and they're starting to talk about things that are really early for us to talk about, like super intelligence. We still don't understand
I don't.
For us to discuss super intelligence. And what is super intelligence? What do you mean?
I mean, when a drone comes to my house, what if there would be a camera attached? And what if there would be the government? Just for example.
Privacy issues.
Yeah. So if you have drones that fly everywhere, every day, to every house, then you don't have privacy. They know if you are out the house, if you're off work, they know everything.
No, they won't know everything. I mean, once you step out of, regardless of drones, let's say you're in your home, and once you step out, you're in a public space. the government has the right to monitor and make sure the public space is secured and whatever.
True.
But it's not a privacy issue unless the drone actually comes into your home and hijacks your your entire house. So I don't see any privacy issues. You mean, yeah, you mean they can monitor you? I mean, they can do that already, I think, with the cameras that are installed in the streets. I mean, look at the cameras installed everywhere. It's in the
But
millions.
like I'm from a small village, and there are practically no cameras here. So you could have privacy if you throw your phone away. And
Actually, I would argue the exact opposite. I think cameras on the streets will end up maintaining the integrity of the law force. So no cops can do wrongful things anymore. It will make sure that everything is monitored 24/7, 36 degrees, 360 degrees. So it actually ends up helping you more than harming you. It would be the other way around if it was in your private space, in your home or in your flat. That's another issue. But on the public domain, once you step in the public space, that's actually helping us as citizens. This is a privacy thing. I know people would agree and disagree, but that's my
yeah,
personal opinion.
it totally depends on your personality. I mean, I had no phone for 1.5 years, and it was totally fine. And now I have one, and I know that there is like someone knowing what I do, because that was funny. In work, I had my Facebook app open, and I was not friended with a colleague of mine, but it suggested that I should chat with him because he's near. So Facebook knows when two people are near each other, which are not friends. So that's kind of creepy. That's the stuff I'm afraid of.
Yeah, I understand your point, and I agree 100%. I mean, you see, privacy issues has been a long thing, and I actually have I have a Facebook, but my Facebook is just I have one friend, which is my business account.
Yeah.
and that's the only, I mean, that's the only reason I'm using Facebook. So yes, I do agree with you that there are limits to everything, and actually you can be overwhelmed by all these social networks, Twitter and blah 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 blah, all this mishmashing of technologies, connecting all your life and bringing them into one page. Yeah, it's scary, because you want some people to share these thoughts or these things with, but you don't want the rest of the world to
Exactly.
So where is the line? Where is Facebook? They're trying to offer all these security measures, filters, whatever, blah blah blah. But at the end of the day, it's just it's hard. So if you are bothered by technology or social media, you can.
Yeah, that's my point. If you are on Facebook, you can unregister yourself. They still have the stuff you wrote on there, okay, but you can go and say no. With like drones or this AI, you could not, because you at some point you can shut it off. You can just say as a private person, I don't want this, because the government decided, okay, we use drones every day, everywhere, in every space. So all your stuff gets blown into the web and into the nirvana. You know?
Yeah, I agree with you. I mean, for drones, you pretty much can't control this. You can communicate with your local senator maybe and and write him a letter.
Yeah.
But it's the public's opinion that's going to rule in such matters in a democratic society. If you're talking on the level of Facebook, Google Plus, or whatever, you can make that choice yourself. You can just don't use them.
Yeah, and I think that's like those are two different concepts, and the second one, which is like humanity has always its problem. Even in a democratic community, there are issues which just it's evolving all the time and changing all the time, and we never have one point or one system where everyone is satisfied. And if you put the privacy into public with community and democratic issues, that's just too much for me. I don't know. I would rather be just knowing, okay, there's a driver which hands me the package, and maybe its car is driving by a drone or an AI, but not a completely roboted thing that knows everything. Because then we could just stay at home and let the AI do all the stuff out there. And so what's life then?
My personal opinion, I don't think this is ever going to happen.
I hope so. It could.
You know, for us to be living in Europa, let's say, or whatever, where there's a centralized, a huge computer which is run by this AI consciousness that's you know, controlling everything in the city, the laws, the police, whatever, like this futuristic thought. You know, I don't believe. I mean, I wish. I want to be wrong in this. I want this to happen actually in a good way, not in a bad, dark, futuristic way. I want it to happen now. Of course, anything that makes humans evolve will be a good thing. But at the end of the day, personally, I don't think this is going to ever happen unless we conquer some of the deepest questions of AI. One of them being consciousness. What is consciousness? How can we implement consciousness? You know, questions of that realm. Second thing, I think this is also very, very important, and on the scale of consciousness. Randomness. What is randomness? How can we generate a truly random number? That is a huge issue also, because evolution is, you know, evolution comes from, and human intelligence is part of evolution, and evolution comes from flipping some bits on the human genome, on the human DNA. So, and this happens totally randomly. So, and we know that bits are being flipped, but we don't know which bits are being flipped and what is this random force that is flipping these bits.
Yeah,
So,
and that was my point in the thing when I said evolving. So some program made another program which has exactly that flip to it, and at one point it makes cluck 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 because the program is learning how to flip this stuff, and so it will be driving the evolution in a time that is not 1 million years, it's a year. So, you know,
yeah,
because the program understands what we don't understand.
Randomness is totally chaotic. There is no meaning behind it. I don't know. I don't understand it myself, but this is what I think is true. There is no meaning behind randomness. Thus, there is no program that can flip these bits, in a sense. It has to happen. But it's truly these are some of the questions that I think AI has to answer before we can go about saying or speaking about super intelligence and higher intelligence and you know, being controlled by a centralized robot in a huge machine that's controlling everything in the city or whatever, or this world. You know, this is a far-fetched sci-fi thought that is really encouraged, really cool, but we're still very far from it. We're still very, very far from it. I don't know if we ever are going to get near to it with our human stupidity in rapidly marching towards our own self-demise. wars, nuclear weapons, etc., etc. So, so I think we have bigger problems to answer. And
Yeah, but I'm thinking when you said like Google is trying to create an oh God, I hate that. Why can't I say I God,
AI,
AI? Yeah, thank you. I don't know why that is so hard for me. They're trying to create this thing, and why are they trying to create it? Because they want to make something which can make decisions more generalized and better for like a purpose. In that purpose, it could be war. So we feed the machine with what would you do, and it learns and spits out. So I think that's the goal of an AI.
yeah, it's to solve all problems.
Yeah. So when we hit that point, which could be, it doesn't have to be like a huge point. It could be, would you eat that apple or that apple? If it learns that, then it would learn more and more and more because it's self-learning, and then it could decide stuff for us.
Yeah, it could decide on its own. Yeah. Well, that's the whole idea,
Yeah,
isn't it?
exactly.
That's the whole idea, is to reach that point and hope that when we trigger that event of this AI figuring out how to be smarter and whatever, then that AI won't actually flip on us and kill us all. But interesting. I mean, yeah, I love sci-fi. But again, as I said, I don't believe we'll ever reach that point unless we answer some deep philosophical questions first.
Yeah, well, I mean, it doesn't have to be answered. In my opinion,
It can happen randomly. That's what you're saying.
it could. Like, we just have to make a program which really understands what learning is.
And
That's
I
the
mean,
point.
I mean, we do not understand what is learning, we as humans. So how can we create something even by mistake that can understand what learning is? And if we don't understand it, how can we create something that understands it? Do you see the inheritance here?
Yeah, I get your
And that's why, that's what I'm saying. It can happen if we answer like major questions. One of them, and the most important one of them, is randomness. Is maybe if we don't understand them, then we can create a chaotic environment where things can evolve into something smarter than us. Maybe. But but for us to be cocky enough to say, hey, we can create a brain better than our brain, I mean, that's way far-fetched. And there is a good quote by a good scientist. Let me. I actually wrote it down. It's Leon Watson, and he goes like, "If the brain were so simple we could understand it, we would be so simple we couldn't."
Yeah, I got you. But
So I mean, if we can understand our brain, if the brain was very simple for us to understand, then we ourselves will be so simple that we wouldn't understand our simple brain.
yeah,
It's a very recursive thought, but that's
let
the
me
way it
put it
is.
that way. Okay, we have one AI which can learn in just a rapidly evolving step which doesn't contain randomness. Okay?
Mhm.
At one point, it would be so intelligent because it sucks up all the information around the world that it could create chaos on itself because it learned that randomness. So maybe we don't understand randomness in a very particular way all the time. You know, when the AI just puts 1 to 1, this is my random number. How can I create this? Maybe that way. No, maybe that way. No, 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 no. And it tries and tries and tries. And someday it will crack it. And when that happens, it can create itself with random attributes. So we actually don't have to understand it if we just create an algorithm with which can learn. That's my opinion on it.
Yeah, and that's what we're doing. So deep learning and neural
Yeah.
network, deep learning, what AlphaGo is built on it, and so deep learning is learning, is artificial learning, and there are three categories to learning in AI. There is the supervised learning, which is basically you bringing the data to your algorithm and saying, "Hey, this is what I want you to learn. Learn it." And that's why, hence, supervised learning. You are supervising the machine or the algorithm to learn. Then there is the unsupervised learning, which is basically just pressing the on button and leaving the algorithm to learn by itself, which is the hardest learning domain for artificial intelligence. We still don't fully understand it until now, because
Yeah.
how can a machine know if this is good data to learn or bad data to learn, or how to label this data if nobody is supervising the machine? So this is the hardest. And the third part is a hybrid, which is what we're doing right now, and actually, which is, I think, AlphaGo is built on, and many other things, is to teach it some, and from its teaching, it can teach itself some more, and then you have to fix these teachings, and it's a back and forth. Reinforcement. It's also called reinforcement learning. So you have to reinforce it every once in a while to make sure the data it learns is actually correct. So exactly, these are the three methods.
But there's the thing: if you control it to create something correct, then you would never know what it learned if you don't, because we as humans think that part was incorrect. But that's not randomness. That is controlled.
Yeah, you mean if you teach this AI something and then it creates something right, but we as humans, since we don't understand it, we say that it's wrong?
Maybe, yeah.
I don't know. I don't know.
Like,
I mean, yeah, I don't know. Actually,
yeah, it's pretty stupid at first, but when you think of it, that's the randomness. When you have like 3,000 computers making the same learning process, and each step or each result, each end result will be different, because you throw in some random variables.
yeah.
And if you control it in like the middle and say, no, that's wrong, that's wrong, that's wrong, that's wrong, then the output will be the same on every machine, because it learned what we said is true. So we can't know for sure.
Yes, that's true. We can't, if I can rephrase this, we
Yeah.
can never underestimate human stupidity. I mean, and we've done it once and again. For example, in Japan in 2011, just I think 72 hours before the actual tsunami and earthquake, Japan has built this Tsukuba. Tsukuba is a supercomputer, and they had some prediction algorithms running on parallel on the background using I don't know how many million flops of memory and CPU, whatever computations, and everything was right. Everything, and then 72 hours before the actual earthquake, the computer beeped and anticipated that okay, there's something going to happen. This is the epicenter of the earthquake that's going to happen, and I'm advising everyone, blah blah blah. And then, and this is why I'm saying don't underestimate human stupidity. And then all the scientists gathered and they were like, no, there is an anomaly in the data, and I think this data is poorly calculated. This is wrong, bad data. Do you see?
Gotcha.
It's kind of similar to what you're saying, that if we feed these algorithms and maybe if they got us the right question, then maybe we are stupid enough not to recognize the right answer. So it's a similar situation where, unfortunately, I mean, it's not our stupid, it's our limited intelligence in some fields can hinder us in many ways, and our limited intelligence and cockiness. Human beings always pride themselves in being the king of the jungle, and we are the brightest. We've done rockets, we've went to the moon. I mean, we've done everything, but deep down, our intelligence is really limited. Is limited to our context in this.
Yeah, exactly. That's what I said in like an hour before, I guess. When the networking is the real deal here, I think, because like I can't create a rocket. I neither can create the plans for it, or I can't build it. The power is in combining.
Mm-hmm. That's true. And this brings us also to some awesome subject in artificial intelligence, which is swarm intelligence. So it's not only you and me; it's all of us, or the collective intelligence of the human species or artificial species. Also a cool subject. Anyway, I think we've talked about many subjects, and I have to go due to some work I have to do. But it was definitely a pleasure. Seed, right?
Yeah, it's HVLMNNS on the Slack group.
Cool. Anyway, it's been really a pleasure, and I look forward to see you all in 2 weeks' time. So we have this every 2 weeks, a bi-weekly
cool.
event every Friday night.
Okay, cool. Yeah, I'll definitely check it out.
Okay, take care, man.
Yeah, you too.
Bye.
Bye-bye.